Hello everyone and welcome to today's webinar. Today we will be discussing about site reliability engineering. But before I introduce you to the presenters, please take a moment to check your audio visual settings while I run through a few items about how you can participate in today's webinar. Today's webinar will last approximately 45 minutes and will include a Q&A session after the presentation. As always, feel free to submit your questions to today's presenters at any time during the webinar by typing them into the question pane of the control panel. The control panel is situated on the right-hand side of your screen. Okay, it just leaves me to remind you that today's webinar is being recorded and you will receive the recording shortly after the broadcast. So without further ado, I am delighted to introduce you to today's presenters, Devanag Padawala and Chokalingam Ramaswamy. Over to you, Nag.
Thank you so much, Shilpi, for setting the context. Hello all. My name is Nag, and I have more than 2 decades of experience in IT, completely into the non-functional testing space. And predominantly, I've been helping our customers in establishing performance testing, performance engineering, cyber security, site reliability, engineering practices into their organizations. Currently, I'm playing the global practice head role for quality test and leading non-functional testing center of excellences. Chucks.
Hi,
Chucks,
hello all. Good morning. This is Chucks here, and I have over 13 years of experience, specifically around performance engineering and optimization. And I'm like highly skilled in building scalable and resilient architectures, and have exposure towards engineering the reliability upfront, even from the design standpoint. So that's about it. Thanks, man.
Thank you, Chucks. So, participants, I think before we get into the today's topic, site reliability engineering, let me take a minute to summarize about our organization. Right, Qualitest, we are the world's leading AI-powered quality engineering company, predominantly working on next-gen digital assurance solutions with more emphasis in sector-driven solutions. Today, we are clocking close to 7,000 plus employees globally, with 40% women power. We also operate globally across 32 development centers, and in India we have 3 development centers. Right. So without further ado, let me get into today's topic. And what we are going to discuss today is at a very high level. Let's understand what is reliability, the need for reliability, and what would make systems unreliable, and how the skill set, site reliability engineering, is taking front seat nowadays in the software development industry, and what kind of skills, tools, responsibilities that the teams have to adopt to enable successful site reliability engineering practices. And we'll briefly speak about the tools and frameworks in the space. Right. With that, let me get into the actual content. Yes, failure happens. I think we do see this in our personal lives, in our day-to-day in the applications and projects that we're handling. Probably let me start this with a maybe classic example that pretty much all of us have witnessed 6-7 months back. If you remember, in October 2021, there was a massive outage from Meta, right, which brought down pretty much, I think, all the Facebook and its subsidiaries. That includes WhatsApp, Instagram, Oculus, and many more applications. I think this outage resulted in huge challenges, a kind of even public criticism, because it was down for almost 6 to 7 hours. And the impact of this is pretty simple. I think during this outage, many users started actually flocking towards other platforms like Twitter, Discord, Telegram, etc. So the reason, I think the reason was purely like, okay, the loss of maybe IP routes to their Facebook's DNS servers, and within 6 hours they were able to find the issue, they were able to fix it. That border gateway protocols have been restored for the affected areas, and then gradually the DNS servers came up and applications started running. But by then, within 6 to 7 hours, there is a huge impact to user experience, and people started switching on to other services. So what this calls for, right? Its bottom line is pretty simple, right? I think even tech giants like Meta were unable to counter this outage. And of course, there is a huge revenue impact. They incurred almost close to $100 billion loss during this outage. So this purely calls that failures happen, of course, but how do we reduce this outage window, and how do we make our systems more reliable and meeting user experiences? At this point in time, I want to even bring out what is actually reliability. I know I'm not talking about a dictionary definition, but I think from the context of the IT systems, what does actually a reliability means, right? It is a system's ability to continue as is, regardless of an anticipated or unanticipated breakdowns or outages, thus by providing a seamless customer experience. I think this is very important. I think customer experience, customer satisfaction is something that is very relevant. So that's where the reliability part of concept comes in. Now, having understood what is reliability, let's try to understand what would make IT systems unreliable. If you understand, okay, what reasons could cause this reliability issues, probably I think the focus would be more on how to bridge gaps around it. Of course, there are multiple reasons, factors due to which systems would become unreliable. We try to represent it in a fishbone diagram in a simplistic way. There could be even many more reasons. But for example, if you look at some of these reasons, like human errors, the developer maybe can write by mistake. To err is human, right? Maybe he could have made some code level changes, maybe a server name change that could cause catastrophe. Dependency errors, maybe non-availability of third-party services, microservices, or maybe a payment gateway system that will have a cascading effect on overall system. It could be network, any network related issues. It could be packet loss or low bandwidth. Any kind of issues would eventually slow down the overall network and have outage and reliability issues. Same way, application, I don't want to go line by line, but yes, there are multiple issues. It could be at a code level, configuration level, maybe a software compatibility issue. On top of all these maybe issues or that are under our control, there are certain situations, factors which are totally out of our control, which are natural disasters. It could be a fire, it could be a cyclone. We cannot avoid these natural disasters, right? So there are a set of human-made errors, there are a set of natural disasters which would eventually cause outages. But the end of the day, every failure leads to huge loss. In these cases, the loss is in terms of there will be a reputation loss, a productivity loss. Obviously, data is very vital nowadays, data loss, and ultimately a revenue loss. Now, that brings us like, okay, now having understood what is reliability and what factors would influence what factors will influence the reliability of a system. Now that brings to the need of the hour, the skill set that is required, which is reliability engineering. Now let's briefly speak about why reliability engineering is emerging as a specialty skill set. I know, okay, this is a typical traditional model that we are looking at, where I think development teams, their focus would be predominantly on the agility. They wanted to deliver feature, they wanted to deliver the code as fast as possible, because yes, there are more releases falling on. So and they will be releasing more codes and features and pushing towards operations teams, while operations teams responsibility is more towards ensuring the stability of the builds. While they'll be focusing more on maintaining the code and deployments in production, they are also siloed in maintaining the stability of these products. But these responsibilities are currently siloed, and that leads to a responsibility gap, right? While at the same time, business has their own expectations. Obviously, it's collective responsibilities to ensure customers are satisfied with the final output, systems are available, reliable, and thus by generating good revenue. Now, this brings a kind of I know we are talking about three different walls, or maybe three different streams, and there has to be group, there has to be a common skill set that can bring together the expectations from these three walls, I would say probably. Now these three walls are bridged using the skill group called site reliability engineering group, right? That's how the evaluation of site reliability engineering group or the need for site reliability engineering comes into picture. Uh, now, uh, now we understand, having understood that the role of the site reliability engineering in an organization. Now let us speak about how the site reliability engineers, what kind of responsibilities they have to possess to deliver these roles successfully. Right. For that, let me ask Chucks to detail about site reliability engineer responsibilities. Chucks, can you briefly speak about now we have seen the role of site reliability engineering uh, uh, to balance the business expectations, operations expectations, and development expectations. But from the responsibilities perspective, how do you foresee the SRE responsibilities?
Yeah. Thank you, Nak. So, see, from the historically from what our customers are looking for, right? These the responsibilities they actually look for. But I would actually try to consolidate it into a like a 5T kind of approach where all these responsibilities are grouped under like either toil reduction or they are transparent or whether the systems are traceable, whether the applications are tolerant enough, and whether we are able to transform from one maturity to another in a digital engineering standpoint. So most of our responsibilities here are around that. Let's say if you have let's say like error budget, or you have SLOE, SLO, SLA, all these information actually gives insights about your service. And the you have streamlined deployments, and you have reduced oil, which is more towards implementing and improving on a day-to-day basis. So even collaboration actually gives that kind of business proposition, right? So you have more uh, like current day you will have a specific kind of maturity, while the next day you strive to improve your maturity. You learn from what you had as a mistake, as a issue, and then you move on. So these are all the responsibilities which we normally see from any customer. If you can move to the next
Yeah,
slide, please.
yeah. Yeah, I think the responsibilities perspective, I think that's a pretty simplified version, Chooks. But I think what we would like to understand more about is, okay, how do we basically these responsibilities translates into the skill categories, right? Maybe we can also throw some light around it.
Correct. Yeah. See, when we say responsibility, it is obviously I understand it is oversimplified, but uh, most of the site reliability engineers, right? Most of the reliability engineers, I would say, are expected to do set of activities as part of multiple skill clusters. If you look at these towers, right, the most of these activities can be grouped into 5 skill clusters. Let's say predominantly around change management, incident response, non-functional assurance, observability of your entire system, and how do we improve as part of our productivity and on a day-to-day basis. So like I explained earlier, right? So if you look at change management, it is more towards identifying what is the risk of the current releases, streamlining the deployments, and anything that has to do with changes that can affect your stability of your system. Like most of our customers are looking for building like most like they want to be in the agile fashion. They want the deployments to happen very fast, but uh, the more changes happen, the systems are unstable. That's where the DevOps actually came into the picture, right? So having change management is very critical, and having incidents response from an operation standpoint also is very critical. When you say incidents response, how do you handle incidents? How do you identify what is the root cause? What kind of measures do you have? Like, what is your standard operating procedure in case of a failure? You document all those things, build a knowledge repository so that everyone can use it. The typical non-functional assurance would actually help in flavor and sugar kind of SOP. performance engineers would be able to model all your performance workloads, and then they can validate whether the requirements are met, predominantly from an performance engineering, performance assurance standpoint. But with the help of observability, they would be able to span even more, right? So they can actually look for metrics, they can look for logs, they can look for traces, they can have actionable insights, automated notifications, and at the end of day, on top of all these things, the final thing is how do we mature as a service, right? So productivity improvement helps in that fashion. You get a feedback loop established, you understand how the production is being utilized, where the issues are, and in case of an event of a failure, how do you solve an issue? Document all these things in a postmortem, blameless postmortem, everybody would say. You, whosever mistake it is, you try to document what all the steps were happened, what all the issues you identified, what all the measures and controls you have, so that these are not repeated in future. So all these are predominantly what we expect as a skill from an site reliability engineer.
Okay. Oh, but again, I think when we looked at the responsibility list, that looked pretty simplified. I think at a very high level, I know you briefly spoke about that 5T responsibility model. That looks a pretty simplified version. But from the skill category perspective and the capability clusters wise, this looks very detailed, right? I mean, I know you mentioned, okay, these 5 capability clusters, and at each of these capability clusters there are also multiple skills that are required. This looks completely exhaustive, but from a non-functional testing point of view, I think, I know we belong to non-functional testing center of excellence. If I look from the perspective of a non-functional tester, I think some of these capability clusters look so familiar. For example, non-functional assurance, whatever I think we are talking about, the performance modeling, performance assurance, engineering, scalability, and these activities, and a bit of activities under observability TAR, right? For example, I think performance engineers are well versed with infrastructure monitoring through APM tools and a bit of tracing and all these things. But the rest of the capability clusters, they look a bit are out of the scope for most of our performance testers and engineers, right? I think now from that point of view, for me, it is an exhaustive list. Now that brings to the one other question, maybe a clarification, that I know, okay, most of the organizations are also trying to build these capabilities internally, and they are leaning towards primarily towards performance testing teams, right? Now my question to you, Chucks, I mean, I know, okay, we are also in this journey, but what is our guidance on enabling performance testing teams to travel towards this SRE journey and bridging the gaps that you, I mean, I think the capability cluster gaps that I'm talking about. Would you be able to, yeah, please share your thoughts around it?
Yeah, definitely. I mean, I understand that. So, see, from an skill cluster perspective, I understand non-functional assurance, the operational readiness, validation, observability, everything. We are actually on a day-to-day basis doing all those kind of activities. Definitely, yes. But internally, there are incident response related activities, there are change management related activities, there are automations that also are part of our regular roles and responsibility. If you say I perform as a performance engineer, I actually go attend the change approval meetings, and then try to give a go or no go for a particular change. Unless I approve that change, it is not actually going to go to the staging or any other environment, right? When I have a production issue, the prod support team is actually going to reach out to me to understand where the root cause is, how to simulate it in lower environment. Uh, Knowing or not, actually, internally we have been supporting these kind of activities. That's the main reason. If you look at this, the entire slide here, right? This actually explains why performance engineers are our best bet to uh, do all these kind of activities. So if you look at the entire boundaries of individual roles and their activities, right? It is very evident that performance testers and engineers actually cut across our entire roles and responsibilities here with the minimal set of activities which additionally like a developer or a production support engineer would additionally do. Like and as part of business, definitely there are a lot of requirements from the business, and they do a lot of other activities. But from a technicality standpoint, let's look at configuration management, right? Where any changes to the application without any prior approval, and it is stored in a centralized repository, it is actually reviewed and then properly gated. Unless there is any approval, there won't be any changes there. And if you look at the feature development, both from a development as well as a production support, if there are any issues as part of a prod incident, let's say, the prod support engineer would try to fix an issue. That also is part of development. So, and feature rollout is like you developers or production support engineers, they try to roll out a particular feature. There are a lot of deployment strategies there right now, which as part of our business requirements, right? We maintain availability, reliability kind of requirements, correct? So
Yeah.
depending on those factors, the developers or production support engineers, they would actually derive a rolling update or a canary deployment or alpha, beta kind of approach, or they can even go with a typical blue-green fashion, right? Where they have two sets of images available and they'll transition all the users from one version to the other version. A lot of other options are also available. So these, along with postmortem, like let's say once an issue is there in production, prod support team, the operations team would actually engage, try to resolve the issue in a firefighting call, let's say. Once it is done, they don't simply shy away from what they did. They actually document it in a knowledge repository in a centralized fashion so that in case these kind of issues occur, they are now aware what is the issue. They try to reduce the downtime. They try to reduce the time it takes to resolve an issue. So apart from these kind of config management, development, incidents response, and then postmortem of root cause, all these things, right? These are something that not 100% which performance engineer. They actually support these kind of activities in defect triage and root cause analysis, definitely, but they don't own these kind of activities. But apart from that, if you look at all the other sets of activities there, right, they on day-to-day basis are actually involved. They take ownership of all these skills. That's the reason actually I'm saying a non-functional tester or non-functional engineer or a performance architect, I would say, is your best bet. So predominantly performance engineer cut across all these kind of roles, and with a little enablement. No, I'm not saying they are the best 100% fit, but at least 70% of the expectations most of our customers are looking for, they do suffice the requirement, and with a bit of enablement around the gap areas, they should be the practitioners in terms of site reliability engineering, and in no time they can be experts.
Okay. No, I'm definitely, I think, again, there is a good connect between the site reliability capability clusters, site reliability engineering capability clusters that you spoke about in the previous slide, and how those capability clusters are mapped across these various roles, and how performance testing team can actually stretch across these roles. Definitely, I think it is a very clear, I would say, I think the boundaries of NFT boundaries, especially performance testing boundaries, are clearly stretching, expanding towards both shift left and shift right. I think it's one way it is good sign, both from business benefits perspective as well as employee skill enablement. But when I say skill enablement, one clarification. So it's maybe, I know, okay, we are talking about performance engineers having a bit of automation, a bit of IT operations support, and a bit into development. Is there any like, I mean, for if I pick an SRE role as an example, how much percentage of an SRE would be spending in these categories? Will you be able to throw any ballpark number, like a 20% development, or is there any some number that we are typically
So
looking at?
the expectation from the industry right now is like any SRE, right? Typically, he should actually spend 50% on development as well as 50% on operations. So it's
Okay.
not like he will always be on the operation side of things, or he'll always be on the feature development side of things. That's the reason we have this kind of skill bridge or shared resource kind of a model, right? So when there is an issue, they tag as part of the operations team, try to resolve, do on a fire, be on a firefighting call, understand what is the issue. They do feature development as part of the incident. While there aren't any issues, they have good error budgets, and their SLIs are met, and they don't have any issues in your current production. Let's say your build is very stable. They now can concentrate more on a productive feature development. And the moment
Okay.
they start developing, that's when your changes come in and it causes stability. It's like a cycle. So uh,
Yeah.
predominantly they share their activities.
Makes sense. I think I think that's pretty clear. I think it's more like you will have to be on both the shift left and shift right equally. I think when we speak about, again, SRE is a highly demanding skill in the industry currently. I think every organization is struggling. Probably, I think this roadmap will also help, like, I mean, how performance testing team can be enabled to become successful SREs. But Chucks, when we speak about any capability building, we typically speak about the trio, right? I think people, process, and tools kind of combination. So we spoke about what kind of process and what kind of people enablement. Can you also speak about, okay, from the tools and technologies perspective, what tools and technologies that SRE should lean on to?
Yeah, no, so it actually has a lot of tools, I would say. I mean, when you look at like DevOps kind of implementations, like SRE is more towards implementing a DevOps kind of strategy from an software engineering side of things, right? So you are building a stable system more than having it as agile. You are building stable system also. So it actually be in line with what we have as a DevOps toolkit as well. So there are additional tools, definitely. Like if you look at the load testing tools, DevOps actually has the same version. So load testing will have JMeter, and you will have chaos engineering, you will have Gremlin, Chaos Monkey, Litmus Chaos, a lot of other tools. And monitoring, as part of our day-to-day activities, we have a lot of APMs, and we can even configure it in case of an open source uh, adoption. You can have Prometheus monitoring your application infra, and you will have Grafana dashboards easily visualizing all those in metrics, right? So most of our applications nowadays are cloud centric. They are built on a Docker containers and hosted or orchestrated using Kubernetes. So the orchestration is actually taken care of by either applying vanilla Kubernetes, or it can be by using Azure based, or like Amazon based, or AWS based, I would say, or GCP based, right? So all these are from an orchestration, code, testing standpoint. But additional to this, since SRE advocates managing everything in a centralized repositories, right? Our code is actually like stored in a centralized repository. Our configurations are stored in a centralized repository. All the traces, the request, end-to-end request tracing, all the metrics, all the logs, everything is actually stored in a centralized fashion. If you look at Elk Stack, it actually captures all the logs from multiple sources and store it in one single repository. Splunk does it in a commercial fashion. Elk is in a like open source way, right? Distributed tracing, it would be
Yeah.
able to identify the entire stack where you spent more time. Like all these are going to help you from a root cause analysis standpoint. It would provide you insights. And from a toil reduction standpoint, when we are mature enough, what we do is we try to automate. That's where the infrastructure automation, the configuration, automated configuration, and then incident response, notification, all these things comes into picture, Matt. So Terraform, Ansible, Chef, all these are going to help in building an infra, building an application, automated deployments, can happen using CI/CD pipelines. Automated builds can happen using Maven and Gradle. A lot of things are there. So if you look at me,
This
these
is
are all
seriously
exactly.
overwhelming
Yeah.
tool list.
Definitely
Yeah,
yes, but it is not as is. I mean, it is not something. If you learn all these things, you are an SRE. SRE is more towards like getting into the customer landscape, trying to understand what is happening there, trying to learn more. So these are bare
absolutely.
minimum most of our customers are looking for. On top of this, there can be additional lot of other tools and frameworks customer might look for.
Yeah. But I think that's certainly a great guidance on what is SRE role, responsibilities, capability clusters, and the tool set that SRE should adopt. Okay, that looks great, Jokes. Okay, so
So now,
I think
that sorry,
yeah,
Nag. Yeah, that's where I wanted to go. So now that we are done with all these to people process and everything, right? How are customers actually looking for implementation? When we say this is like a big bang approach, right? Day one, we cannot implement all these things. How are actually looking
absolutely.
for customers looking for implementing all these things?
Yeah, as you rightly mentioned, it is not a big bang approach. I know you're also part of some of the SRE journeys that we are helping with our customers. I think as a common framework, our suggestion is, maybe our recommendation is a 4-stage maturity roadmap for implementing SRE. Right? It is, as I said, it is not a big bang approach. It is not a pointed solution. This has to be a journey. And obviously, if you look at the way from crawl to fly, it is more like a chaotic situation to almost like a proactive situation. But definitely the starting point is to probably to understand, maybe work closely with the on-call team, understand what is happening in the production, or how much time they're taking to fix the issues, how many performance related issues, reliability related issues are there for the existing services and applications, what kind of KPIs, SLS are available. I think the first stage is obviously when we talk about the crawl stage. I think organizations are primarily spending time more towards the shift right teams, IT operations teams, and understand and assess their current maturity to embark onto SRE journey. That is the crawl stage, which is more like a chaotic. Then moves on to a walk stage. I think this is where I think NFT SRE teams have to come in, define performance engineering, quality gates, and define the RACI across various stakeholders, including development teams, architects, IT operations team, everybody, and get an agreement on that, get an agreement on SLAs, then start defining even the reliability metrics. I think everybody who goes through this SRE journey, they know the all these SLO, SLA, SLI kind of metrics. I think get some sort of agreement on those metrics. I think that will set you into the walk stage where, okay, you are ready for a journey with a matured performance testing with proper quality gates and a thought process towards SRE. Then that brings you to the run stage. This is where I think the critical part of it is having a change governance and having approvals for release based for every release, proper assessments, and more in terms of now I think in the run stage only we bring the shift left alignment also. Right? This is where the fault tolerance should not be, of course, not be shift right activity alone. This is where you'll have to work closely with the software engineering teams, development teams, instill the thoughts around bringing in reliability thoughts into the code itself, right? I mean, how they can bring these tolerance, right? Maybe, for example, if you're talking about building microservices based applications, how even the kind of rate limiter, circuit breaker, retries, time limiters, all these things can be added during the design and development stage itself, so that, okay, these before these small issues becomes a cascading effect at a code level, they will be arrested there, right? So basically, the journey, if you look at the ship right element, work with IT operations in the early stage, then establish proper gated checkpoints and have right governance, start introducing the full stack observability and all those concepts that just you spoke about, chaos engineering and all that. I think this sets you to run a decent SRE practices in the organization. Again, you mentioned, I think toil reduction is something a more mature organizations would do. Yes, yeah, once we have proper controls, SRE controls and practices in place, I think you look for the proactive activities like, okay, how do we bring in self-healing? How do we bring in AI capabilities into this entire monitoring framework?
I
Right?
have
How
a
do you
question.
think about it? Yeah.
So if you look at this pack, right, the full stack observability and proactive monitoring, I'm still not clear. How does it actually differentiate? Both are monitoring, right? In terms
Yeah.
of understanding the
So
usage.
yeah, so I think full stack observability I think this is more about setting up something at a tech stack level. Proactive
Mhm.
monitoring is also based on like you from your post-mortem reports and following through latest trends and what is happening. So taking some proactive measures on the monitoring part, user experience monitoring part, right? So these two, when these two things come together, full stack observability and proactive monitoring, you have the complete coverage on your business process monitoring.
Okay,
So
got it.
that is yeah. This is a
It is more
four-stage
of a
monitoring.
reactive approach. I get it. Yeah. Okay.
Correct. Yeah. And I would say, I think most customers or most organizations who are in their roadmap journey, most of them are today, I think either they are in run or walk stage. The very few mature customers, as you also highlighted, some of them are in fly. But yes, many organizations are on their journey towards this walk and run, right? So maybe I'll spend a word of just a minute on this also. Again, what kind of models these organizations are implementing? There are two different models that we are talking about. One, an embedded SRE model, which is more, I would say, probably the focus is more about how to build the resilient product. How to build a resilient product in this case. In this case, SREs are part of the development team, and they provide these reliability guidance to them, right? But the disadvantage in this model, as we could see, right, the knowledge is siloed here, right? It is not cascaded across the enterprise. That's where actually the centralized SRE model addresses that problem, right? Centralized SRE model is predominantly to mature the SRE technologies practices across organization with the knowledge delivering across. So that's how the models are. I think having seen these models and having heard all these things, right, the responsibilities, roles, tools, technology skill set, the maturity roadmap, and what kind of engagement models, this clearly shows how businesses can actually start identifying these SRE skills, how to groom these skills, what kind of models they have to follow for getting broader business benefits. I think from the maybe let me also conclude this by saying business value proposition is pretty clear. Once you have an SRE and SRE practices in place, that will lead to lesser outages, that will bring you the cost of fixing the production incidents, streamlined operations, absolutely. And of course, as we just spoke about the proactive monitoring and observability, we are trying to minimize the risk exposure on your tech stack and the systems by minimizing the overall risks. Ultimately, that will lead to the customer experience, right, which is what business also looks at. So those are the business value propositions from the SRE implementations perspective.
Okay.
Yeah. So maybe the last one, probably, I think we would also say from on the quality test side, right? I mean, how are we actually offering this value proposition to our customers? Probably, I think I'll probably request Chokes to speak about this. The quality test value proposition is observability lens. This is our internal in-house reference architecture framework for our SRE implementations. Maybe Chokes, you can speak a minute or two about this framework before we wrap.
Sure, thank you. So most of our customers are actually looking for open source reference architectures, right? They want to see a sample and they want to implement similar in their infrastructure as well, right? Be it an typical IaaS-based application, or it can be a Java-based or Python-based, any application. And it can be hosted on a infra regular VM as well, or it can be hosted on a Kubernetes platform. It can be hosted on an OpenShift platform. PCA. A lot of focus areas are there, but all of these are actually looking for metrics from application, from infra, from platform, logs from all these components, and traces to understand individual components span. Like in a general picture, like let's say there are 10 seconds where or which component I spent more time. Like try to understand where exactly I have to optimize. Within that, if I'm able to get into that particular component using the stack traces, and I'll be able to understand where exactly I can optimize further, right? So these are all from an eagle eye view, while we are now actually talking about incorporating the reliability and resiliency into your application itself, right? So chaos engineering actually helps you in validating that. It actually inject faults, it actually into the infra and platform, while how application validating how application is actually fault tolerant, basically. So all these are from an open source standpoint, and on top of these, all these are in a centralized Grafana repository here. So these information then can be extracted using all the APIs that are available from Prometheus or any open source APIs here, right? So you'll be able to build on top of all these things. You can build smart performance monitoring solutions. You can build insights. You can do a lot of self-healing and automated incident response and everything. There are a lot of possibilities here. So a good thing is these are all built on open source, so we can extend heavily.
Yeah, I think that is the beauty of it, right? I think we can build
Yeah,
the entire observability end-to-end framework using open source tool stack. I think that's
right.
where I think the benefit also comes here. I think that brings us to the probably the last leg of the today's session. The most important part of it is Q&A. Shilpi, do you see any questions coming up in the chat box so we can pick up? I know we have another maybe I think 4 to 5 minutes, but do you see any questions coming up? We can pick up a few questions.
Sure. Thank you both. Yes, I see few questions in the question pane. Here's an interesting one. What level of SRE activities can be performed in lower environment? Who
Lower
wants that?
environment, is it? Can you repeat the question, Shilpi?
Sure. What level of SRE activities can be performed in lower environment?
Okay, lower environments. So Chuks,
I'll take that.
yeah,
So
yeah, please.
so see, like I explained, right? Performance engineers or performance testers, by like I was explaining how they were the best bet in terms of all doing all these activities from an SRE standpoint, right? Same fashion, as part of any production incidents, let's say, we simulate that kind of issues in our lower environment. So all those towers, except incidents response, which is related to actually production, we try to like simulate it in lower environment, identify there are any issues. Apart from that, most of the activities that are part of non-functional assurance, observability, and then change management is actually in terms of the lower environment. We do all these changes, we monitor all these things, we validate and assure performance, business continuity is validated. A lot of things are something that we can actually do in lower environment itself. Even to nowadays, chaos engineering, the fault injection are not happening actually in production. They are doing it in the lower environment, validating the design of your application itself. So a lot of these activities actually help as like when we do it in lower environment itself. Even the productivity improvement, right?
Yeah,
We can actually automate all these things in lower, but it can be implemented in production also. That is where the beauty is. You just change the servers and it automatically runs that. That's what automation is for.
yeah. I think
Do you
okay.
have any other questions, Shilpi?
Yes, Chokes. Thank you for answering that. We have a second one. Here it goes. Based on your experience, which sectors are looking for reliability engineering services?
Okay, I'll pick
So,
that. Yeah, I can pick that. See, I think the moment we say reliability engineering, it strikes to all of us is the site reliability engineering, and I think for the last few years, we are seeing demand naturally in the industries like retail, travel, hospitality, energy utilities kind of sectors where the enterprises are trying to make their applications available 99.99, 99.9 and 4 nines, 5 nines kind of availability to ensure okay they are providing seamless customer experience. I think while those are the predominantly the major industries who are consuming site reliability services, we have started seeing a kind of a shift or maybe a new trend in other sectors as well. For example, medical devices or life sciences industry is actively looking for reliability engineers nowadays, right? I think be it their ultrasound devices or CT scan devices, or be it even ophthalmology instruments, there is a sudden surge in reliability engineering requirements across these medical devices industries. That is one trend that we have started noticing. And the other industry is also like the telecommunication industry. Yes, I think that is also another sector that has started embracing reliability engineers. But the difference here, maybe let me also just highlight the difference here, right? I think in case of these retail and all other applications, we are talking about application reliability engineering, mostly towards either mobile applications or web applications, right? Whereas when you're speaking about telecom industries, the emphasis more on the network reliability than application reliability, right? I think probably if I have to put a word or two about it, is like how reliable are the networks when the user is on a domestic network, when the user is on a roaming network, right? I mean, how do we test it from a performance and reliability angle? The same way, when we speak about the medical devices and life sciences industry, the emphasis is not on the software that controls these the devices. It's more on the devices itself, right? Of course, it is a regulatory requirements that okay, all these devices have to be reliable. They have to be, precision wise, speed wise, or devices have to meet certain guidelines. But yes, the expectations are more towards meeting reliability requirements at a device level, network level. This is a new trend that we have started noticing for the last few months.
Thank you, Nag. We have time for just one more question.
Okay,
here it is. When customers today are moving towards cloud adoption, why should we worry about reliability, as cloud service providers would take care of it for me?
I'll pick it up.
Okay, good.
Yeah. So actually, it's an interesting question, but when we actually move into the cloud operations, cloud environment, right, it doesn't actually say that your application is reliable. It just means that your application is available most of the time. So your cloud provider is actually promising you the availability of your application because of their highly available data centers. If you are not actually using AWS services or Azure services, the products they offer, if you are building your own application, let's say your own enterprise application on top of the cloud provider's infrastructure, reliability engineering is a must actually, because your application, like by magic, cannot be fault tolerant. It needs to come within the design actually, and the cloud provider doesn't offer you reliability, they offer you availability, correct? So reliability is more towards how they are functionally available and operational, I would say. Unless you do reliability engineering starting from your design, where you validate the failure modes, you validate reliability of your individual components from a scalability standpoint, also you validate from a capacity standpoint, you validate a lot of things. If we are building our own product, definitely we need to make sure from the scratch we are doing things, be it hosted on premise within the customer's landscape or data center, or whether it has been hosted on a cloud. Reliability engineering is a must.
Thank you, Jocks. I do not see any more questions in the chat box, so I think we have answered them all. However, if anyone is in the middle of typing your question, do not worry. We'll pick up your question and reply to you after the webinar. Now, it just leaves me to say, Nag and Jokes, thank you very much for presenting today and sharing your wealth of knowledge. And an extended thanks to you, our audience, for joining us today. Just a heads up, to sign up to any of our webinars, please visit qualtestgroup.com/insights/webinars. Until next time, when we look forward to you joining us again, all the best and goodbye.